So I picked up this Sherwood AV receiver off eBay, local to me. Winning bid was $1. The listing did say it was dodgy, doesn't quite turn on, or at least power cycles. So I thought, oh well, it's a pretty cheap challenge. Let's see if we can get it going. Even comes with a remote. So the listing did say that it doesn't power up. I have not cleaned this or anything since bringing it home. It was only local to me, about 15 minutes drive. So we'll see what it gets up to when we try to power it on. So hopefully it doesn't completely fail and burn the shop down, but what better way to find out? So I've got the trusty hoppy here. So what I do plan to achieve is just to see if there's any residual current draw or power draw while in standby mode. It does have a soft power on, so that means it's got an electronic or a logic behind the power on. It's not one of those solid clunky on-off switches. I mean, it does feel, the button feels well used. Sleep button, and you've got the speakers, A and B speakers. Everything seems to feel really good. The bass and treble dials here feel well damped, although this one's got a bit of a wobble to it, so it looks like it's taken a knock. The bass is okay. The volume knob seems to be smooth enough. It does have the LED indicator, but I've not powered this up since bringing it home, so you're going to find out exactly what state it's in at the same time I do. All right, let's just reposition the camera and get the hoppy all set up and then go from there. So I believe this unit is 90s vintage. I'm not too sure when. But mind you, it was a quick and dirty search. So got the hoppy all set up, got the power cable, which is no longer compliant because we haven't got the half of the pins haven't been insulated. So this is definitely shows its age because we've had that in Australia at least for a good 15-20 years now. So currently showing 240 volts at the supply at 50 hertz. So we'll plug this in and see what happens. Okay, we're drawing 2.3 watts. Power factor is 0.5, drawing 15 milliamps. So there's no sense of life. Just move this light out of the way. Oh yes, hang on. We've got a standby light. So we do have standby logic available to us. Hopefully you can see that screen. Okay, well let's see what happens when we hit the power button. Whoa. Oh no. Not great at all. It's trying to start. I'm actually wondering if the old transformers shit the bed. Okay, anything we can do now is open it up and take a look inside. So cosmetically, it doesn't seem too bad. I mean, it does have some scuffs and scratches. This looks like it's been sitting on its side and dragged along the floor at some point. So it is very dusty and a bit grimy. But I wasn't going to spend too much time cleaning it up if I can't get it working. So why did I buy this? Oh, I just wanted something to do. In fact, I placed a bid on this unit as a bit of a joke because I probably knew I wouldn't get it for $1. Lo and behold, I woke up the next morning and have notification that I've won the bid. And goes, oh well, why not add $1? Not much I can lose. But I thought it'd be fun to have a bit of a repair video or some content for a repair video on on a mid-90s, well, I suspect mid-90s AV receiver. I can certainly put it into good use in the shop and get a bit of old equipment back up and running again, so someone like myself can enjoy it. I do currently have a Sony receiver running in the shop that's running the big speakers. Don't mind my bugs up there. It's not the amplifier. I do have a UPS currently under repair. That's going to be another video. So hopefully that works out favorably. I'm still actually shooting that video, so I don't even know at this time if it's gonna work. Okay, so let's take a look inside. Now, there's nothing outwardly smelly about this unit. It doesn't appear to be burnt out, but this may reveal all. Just pop this cover over to the side. Okay, what I might do is just stand it up on its edge so you can have a look. And I shall reset the camera. Okay, so you can see inside, being the big power transformer at the top, into the sub power supply board, what it appears to be here. We've got some of our input board here. Underneath that board we have our outputs, which is powering our larger speaker terminals from the power amplifier section of the circuit. And we've got our display logic and Dolby Pro Logic processing up the front here by the look of it. Now I can't see anything obvious as far as, you know, massive burn marks or even missing or blown fuses. Everything seems to be intact. But what I will do is quickly buzz out all the fuses that I can see, just to double check that we haven't got an issue there. Everything seems to be attached. All the cables and whatnot around the place seem to be good. So I guess this relay here is the one that we can hear clicking on and off, which probably brings the main power to the power amplifier online. So what we might do, rather than strip this down any further, is I'll buzz those fuses out first and go from there. Okay, a couple of fuses up on the top near the power relay. That one's fine. That one's good. That one's good as well. All seem to be okay. And the fact that they're not blown sort of lends weight to that there's not a critical failure somewhere, but just maybe we've got a dead cap, shorted cap or something on the logic section, or the relay's faulty even. Could be any number of things. Could be this MOV. But what I'll do now is just spend some time sort of tracing the high voltage side of things and go from there, knowing that we have got some sort of low voltage existing in the system to power the logic circuits. So I'll just trace that around and see what we can find out. Just decided while I'm trying to reconfigure the unit to work on it, we're going to get rid of this AM loop aerial or antenna because, who listens to AM nowadays? Okay, so I've just repositioned the unit so we're looking directly down at the power transformer area and what they call down here the power supply board. Part of my problem shooting, I just want to find out whether or not we've got an issue where when we turn on the unit, the high side is bringing the power board down and causing that clicking, that constant clicking loop, or we have an actual issue with the low side switching circuit, whether it has a problem on its own, causing the high side, or I should say the power side, to cycle like it is. So what I've just had a look at is this black and white cable coming down into this power supply board is the main feed into the power transformer. So what I might try and attempt to do, a side note, I found two more glass fuses, the 20x6 or 20x5 I think, glass fuses here, and they both still tested okay. So I'm starting to think, let's eliminate some of the circuit and see whether or not we can either change its behavior or, you know, sort of find some clues as to what's going on. So what I'm going to do now, I'm just going to unplug this black and white cable and just put that to the side like so. And we'll plug the unit back in and hit the standby button or the power button and see what happens, if anything. So plugging the unit back into the hoppy, so far nothing, but we do have a standby light. Rather than reset the camera, you have to take my word for it. So what I'm going to do now, I'm going to press the power button and we'll see what happens. Aha! Right, so now we've got that clicking function again. But then trying to cycle the power button doesn't stop the behavior. nor does the sleep button. Okay, that's interesting. Righto, so I'll unplug it, disconnect the power to the unit, and what we'll do, we'll plug our power transformer back in, back into the power board, and see if the behavior changes again. So we'll plug it back into the hoppy. Now we've got the full, you could tell that the power transformer is trying to kick in and it's creating that thud. So now it's not latching. Okay, the behavior of the power button is quite sporadic, where it may latch sometimes, but the button isn't physically itself is not a latching button. It's something to do with the circuitry here. So if I give it a light touch, oh yeah, I can get it to activate. Oh yeah, now it's behaving. So it's a little bit, it's actually a little bit intermittent. Right, I'm going to unplug the unit again and disconnect it. Now down here we see a heat sink. I don't want to be touching that while it was plugged in, so I just want to check to see if that is actually getting hot in any way. Now I'm guessing that is a linear regulator, and that linear regulator is responsible for supplying, I guess, some logic voltage, maybe around 5 or so volts, to the soft power on functionality of the power board. So I think what's left to do now is maybe we'll chop some of these cable ties out of the way, and we'll have a good look around to see what's going on, what inputs and outputs we have. The board itself does appear to be marked up to a degree, which is going to be quite handy for troubleshooting, seeing whether or not we've got the right voltages present at certain points, and we can go from there. Actually, just while I'm here, let's just see if we can spot any date codes, just to see when this might have been manufactured. Okay, we've got a IC up here. Doesn't really give us anything. Actually, I'll do that off camera. If I spot anything, I'll let you know. So I've been doing a little bit of jiggery pokery around this power supply board, and I think I'm going to take it out and have a closer look at the underside of it, because I have noted down near this little tiny transformer here, which is responsible for supplying about, I don't know, 10 or so volts to the input side of this reg here, the 6 volt reg. Some components have a little bit of corrosion around them, so I just want to see what the underside of the board looks like. I think before I really strip this down to try and get this board out, I'll have a look from underneath and see if I can take the bottom chassis plate off and see what I can see from the base. But I'm starting to think there is an issue this side of the circuit, because every time this relay clicks in, it pulls everything down. And on top of that, this relay is a 12 volt relay, but unfortunately it's served by a 6 volt rail. So I'm not too sure what's going on now. I'm going to have a look at the service manual. I'd managed to download one. Yeah, lo and behold, this does actually say 12 volts, but powered by a 6 volt rail. But anyway, we'll reconvene shortly once I've got the base of this unit off, and we can have a closer look at the base of the power supply board. You know it's good quality when you got gold bands around the feet. Just screams elitist. Capitalist. Haha. I was quite fond of the old 90s sort of stereo gear as growing up as a kid. I remember going to my grandparents' place, and they had this sort of gear. Well, that's not going to give us much indication on the input side, because there's a power transformer, and this is where the board sits for the good old logic and low voltage stuff. So I may have to remove that board from the top. Okay, for the time being, I'm going to put this back on, because I don't really need to do any testing in this area yet until we have a bit more detail. So I'm going to screw this back on off camera, and then we'll go back to removing the board from the top of this unit. So I have got the power supply board out. I'm just going to pop this, it's all discharged at the moment. I'm just going to pop this ice cream lid just underneath, because it does have mains connections underneath there, and I want to try and fire this up while I'm taking some measurements. But first off, we're just going to give this a visual going over. Can't see anything off the bat. You can see that this area here is the little low voltage transformer to give us our localized logic voltage for the soft on system. Now I can't see any, although there's a couple of dry joints around the place. Right, I might just get the old magnifying glass out and give this a good going over, just visually to make sure. I can't tell whether or not there has been some service done on this since being out of the factory. I'm going to say no at this stage. So I've just decided to have another look at the schematics for this unit. So with the power supply board out, I've been just poking around. Now what I have discovered though is low voltage standby transformer is this guy here. Goes through a 350 milliamp fuse and then through a diode bridge and then across to this filtering cap, which is C554. So 554 on the board itself, it's supposed to be a 220 microfarad 16 volt capacitor, but in this case it is 470 microfarad 16 volt. Not that it matters much, you get slightly better filtering. The problem is we've got a 10.7 volt input, and then once filtered on this capacitor here, we should have a voltage across the relay system, the relay here. The negative side of the relay is switched through this transistor from a signal coming from the CPU board. So that CPU board signal seems to be present, hence why it's triggering this transistor, trying to turn on this 12 volt relay. You might remember me saying it was 12 volt earlier. So 12 volt makes complete sense, because once we have this diode bridge filtering the AC coming in, we should see about 10.7 volts as it says here. We're getting 10.6 directly out of the diode bridge, which is fine. But at the moment, this capacitor here, it's just starting to rain, sorry. This capacitor is not showing anywhere near 10.7 volts. It's actually down to about 8. So I'm just wondering if this capacitor here is gone high resistance and the ESR has gone through the roof, or in fact, we've got some issue here. This 10 ohm resistor, it's just basically a link. That's tested fine. The diode's tested fine across the coil of the relay. And obviously this transistor is working because it is driving the relay. I'm starting to suspect that the supply voltage to this relay is too low, and it's just not quite enough to keep the relay energized, and that's why we're in this cyclic loop. So what I might do, I'm going to pull out this C554 from the power board. I'll just run the ESR meter across it and see what happens, see what reading we get. So the capacitor that's at fault, well, suspect of being at fault, is this one right here. So what I might do is I'll bring over the solder sucker and we'll just quickly whack that out and we'll give it a test. In fact, I might just test it in situ. We'll go with that. Test it in situ and see what reading we get. Okay, I've got my ESR meter ready. It's just this little MESR 100, great little meter. It's supposed to do in situ component testing. So for a 16 volt, well, in this case, it's a 470 microfarad capacitor. So we're looking at, we don't want to see anything higher than probably 0.18 ohms. So let's just have a quick look. So we know the negative terminal is on the outside of the board. So we'll clip that in there. We'll clip our negative, trying not to touch the leads together. Oh wow, don't know if you can see that, but it says 16.8 ohms. I think we'll drop that cap out. We'll take it out and give it another test outside of the circuit. Okay, so just apply a little bit of flux to our little suspect cap here. Everything's discharged, so there's no voltages left in the mains caps. Not that there is any mains. And yes, I reviewed this solder sucker or desoldering gun over a year ago now, and it's still going great. I get the odd question in the comments on the video every now and again. Okay, so that capacitor's been removed. 470 by 16 volts. Let's go get the tester. Negative terminal, positive terminal. Okay, so we've got 13.8 ohms. Don't know if you can see that. 13.9. So that capacitor is completely cooked. I might change it out for a new one and go from there. I'll be right back. Just got to go through my capacitors. Okay, so I've got a brand new, cheap, nasty, what brand is it? Huahong brand, but it's brand new. Let's run a test on it and we'll see what it's at. But I'm actually going to replace the 470 that's in there. I'm going to put the 220 in as per the circuit diagram, because that's what it calls for. But this is rated at 25 volts instead of 16, so we've got a bit of headroom there. Okay, so 0.1 ohms. So for a 25 volt electrolytic capacitor at 220, it should be anything below 0.33. So that's definitely within spec. So that's nice to know. It is a physically smaller capacitor. Well, I mean, this is the 470 that we took out, but we are going to put a 220 25 volt in. Never mind. Now, I'm not under any illusion that this will actually fix our current fault, but certainly can't make it any worse. And no, I haven't, this unit's not plugged in, so I'm quite all right handling it. So we'll do negative that side and then positive. I won't cut the leads straight away. We'll do another test first before we snip the leads. I don't think this is going to fix the issue, but I'll leave those leads nice and long in case we want to throw test equipment on it. Let's just turn my soldering iron on. So there, this soldering iron has still done me proud. The old KSGER. I've done my review on that many moons ago. It's still my go-to. So we'll give this a bit of a tickle up. Nice fresh solder with a bit of flux. Perfect. Okay, I'm happy with that. Just reposition our board so we don't fry something. I'll just plug this into, excuse my shoulder at the moment. Okay, that behaviour was a lot different. I'm just going to hit the standby button. Are you kidding me? Okay, so that goes back into standby, maybe because I know the main power transformer is not plugged in. So what I'm going to do, I'll just quickly turn the power off and unplug the unit. Just wait a few seconds for those, or any caps to discharge from mains. But really, This is a linear, it's a linear power supply. There's no real mains caps. It's not like a switching power supply, but I will double check. Okay, nothing. All right, basically nothing. Okay. Let's put, now where's our transformer? There it is. So the white and black connector to the transformer. Pop that back on the switched output, which is driven by this relay. And what I might do is just quickly rotate this a little bit so we can see the front. See the front of the unit. Just reposition the camera. So I'll bring you down a little bit. I'm not holding hope as this being the fix, but if it's just, well, a 2-cent capacitor, it'll be phenomenal. That's what the problem was. Okay, so plugging the unit back in. Now watch for this section of the display because there's a standby light that should pop in within a few seconds of switching it on. Yeah, we see that. Don't know how well it comes out on the screen, on the camera. There, you can see it there. Okay. Just back this off a bit. Okay, let's see what happens. Fingers crossed. You're actually joking. Well, there it is, folks. One capacitor was at fault. Let's do a couple of power cycles. Unbelievable. Absolutely phenomenal. Well, this is only part of the whole repair series, because at the moment I know that this now fires up. Display's nice and crisp. All the functionality from the buttons. The only thing is now, does it actually make sound? I mean, we do have a test tone, but I've got no speakers hooked up to it at the moment. So I think I will leave it here for part one, now that we've got the machine firing up and turning on, and it seems to be making all the right noises. And we'll do an output test in part two. Hopefully enjoy that. If you found the video useful and this might help in a repair that you might be looking into, or a project you've got on one of these Sherwood branded AV receivers, feel free to give us a like, subscribe, and tell all your friends and family if they decide to get their soldering iron out and have a bit of a tinker. By all means, do things within your own skill set. Don't attempt anything that you're not sure of, especially when we're dealing with mains power. If you are confident in yourself and you have all the safeguards in place, then it's quite rewarding to have something repaired. Like I say, I picked this up for $1 on eBay. Didn't expect to win it. It was local to me, 15-minute drive, picked it up, and look, it's taken a 5-cent part, if that, and the thing's fired back up. There you go. Thanks for watching. By the way, remember when I said, well, we replaced that capacitor because there was only about 8 volts across it. Let's just test it now with a fresh capacitor in there and see what voltage we've actually got across it now. Hopefully you can see the multimeter. I might just jump around the other side so I don't block your view. We'll just quick test and see what we've got across it now. 10.7 volts. So just because that resistor, that capacitor was high ESR, was pulling the voltage just low enough that when the relay kicked in, it just wasn't quite enough voltage across the winding to keep that relay engaged. Hence why we ended up in that loop. Ha! Some of the simple things, eh?